Assalamualaikum, good morning, and good afternoon. Good afternoon, everyone. Okay, I think we can start. Yeah. All right. So let's resume our lecture. Um, all right. So previously we have talked about LU2, isn't it? We're still in LU2. So LU2 again is about non-parametric tests. We have covered sign tests and then followed by Wilkinson sign rank tests. And then Mann-Whitney tests, followed by Kraskell-Wallis tests. Okay. Right. So each of these, it has its own characteristics. So the difference between sign tests and Wilkinson sign rank test, sign tests only consider the signs, right? The difference. Talk about comparing two samples or two sets of data. But the comparison using sign tests is just to take note whether it's bigger or less, isn't it? With Wilcoxon sign rank test, we consider the magnitude, right? But both of the two tests, yeah, Wilcoxon and sign test, they are used for dependent data, okay? And then for Mann-Whitney test, is designed for analyzing two independent samples. So that is the most significant feature of Mann-Whitney test. Okay. So when you are given a data, you have to analyze what kind of data you are analyzing. And then last week we talked about Kraskell-Wallis test. So Kraskell-Wallis test, if Mann-Whitney is used for analyzing two independent samples, Kraskell-Wallis is used for analyzing more than two independent samples of non-parametric data. Okay, so that's the difference between Mann-Whitney and Kraskell-Wallis. So today we are going to talk about the last test of non-parametric test that we're going to cover in this course, which is Friedman test. Okay, Friedman test. So what's the difference between Friedman test and Kraskell-Wallis? So if Kraskell-Wallis is designed for analyzing more than two independent samples, but we are just focusing on one factor. So for example, if we want to compare three samples or three groups of students from different schools, school A, school B, school C, right? So if let's say we just want to analyze their performance of maybe statistics, statistic marks. Okay, so the factor that we want to analyze is the statistics marks, right? So that is the factor. So we are comparing the three groups. But if let's say we want to compare, let's give an example. So by the way, I have forwarded the steps for the Friedman test in the Telegram. Okay, so please have a look at it so we can refer to that steps after this. Okay, so back to my point just now. If let's say we are analyzing school group, say group school A, school B, and C, and we are analyzing their statistics marks, for example. statistics marks. So of course, school A, it has its own data. School B and school C has its own data. So here, this one is the factor, the thing that we want to compare. Okay, so in this case, because our factor is only one, okay, we can use Kruskal-Wallis, right? Because the factor is only one, and there are more than two independent samples. Because in here we have three, so we can use this test. But what happens if, let's say, we want to compare statistics marks for all the three samples, the three groups, but then we want to also compare, let's say, we want to have this one, right? Okay, this is factor one. And another thing that we want to compare is we want to compare how the male, female students across the groups, how's their marks, the performance of statistics across the group. So it means that I want to compare the statistics marks of male students from school A, and then how it differs with school B and school C, but only male. Yeah? So it means that I introduce another factor, which is here is the gender, isn't it? So, but still within the same, like the same samples, the same three samples. So this is actually factor number two. Factor number two. So the first one just now is statistics, whether the marks, and the second one is the gender. So I hope you can see the difference. So if let's say we have another factor, we want to introduce another factor in our samples. Our samples are more than two. So in this case, we cannot use Kruskal-Wallis test anymore, but we have to use a test called Friedman test. Okay, provided that our data are non-parametric. Yeah? Non-parametric. Okay, so that's the difference between hold on, now I have a call. All right, madam. Hello? Sorry? Yeah. Can you make a call? I have a meeting later at maybe 4. Can you Nurul Zawiya? The one that hello? Yeah. Can you call Nurul Zawiya? Okay, okay. I'm sorry for that. Because it's it interrupts my iPad as well if I don't answer. Sorry for that. Okay, sorry. Right. Where was I just now? Friedman test. Okay, so in this lecture we are going to cover Friedman test. Okay, Friedman test. Okay. So what is Friedman test? So just now when I introduce this the second factor, yeah, factor 2, which is gender. It could be any types of factor. It can be gender. It can be also maybe let's say year 1, year 2, year 3, for example. So my factor is instead of gender. So the factor, it can be anything. It Okay, so what I keep here is just an example. So Friedman test is used for analyzing what we call randomized block design. So this kind of data, when we have two factors, the whole data here, we call it randomized block design. Okay. And the second factor just now is also known as block. Okay, block. Because we create a block inside that. Okay. Right. So that's randomized block design. The Friedman two-way analysis of variance by ranks test the null. Okay, so means that we are comparing, we are still comparing the three samples, but in a way that is when we have the block, it means that we would have more specific comparison. For example, if we want to compare just male students across the three schools, means that our data will be specific, isn't it? So our data, our comparison is just based on the gender, but based on the three schools. Rather than if, let's say, we don't consider the gender, we want to compare the whole students of group school A, the whole students of school B and school C. So that is actually less specific. Okay, so that is the benefit of having a block. Okay, we can have a more specific results or comparison. Okay, so since we are still comparing, so we need to say that when we want to construct the hypothesis, so now we have to be specific with our case, right? So our hypothesis, we would say that there would be okay, null hypothesis, alternative hypothesis. For null hypothesis, there is no difference. Okay, obviously there is no difference between school A, school B, and school C. But if let's say we want to say our alternative hypothesis, there is a difference, right? Okay, so but you know now the difference, how the difference will be. The difference will be between school A, school B, school C in general, and also if let's say we want to talk about just male students or maybe like across the block. Okay. So I think that's explains this one. So here are the steps, the steps of Friedman test. So the first step is always to understand the problem and set the hypothesis. Okay. So you have to refer to your problem specifically and state specifically the samples. If it is false, state false. If it is team, state team or whatever. Okay. And then the second step is to rank the data within each block. Okay, now, so once you have given a data to be analyzed, so the first thing, apart from setting the hypothesis, you also have to identify, please jot down because it's not in the notes, I think. Identify what is group or treatment or sample. Okay, and then the second one is block. Okay, so just now when we have an example here, so this one is block, right? And this one, like different types of schools, is actually treatment or is actually sample. But after this, we're not going to say sample because it's more to like they use the term treatment or group. Okay, but you have to know that it's actually referring to the sample. Okay, treatment, group, sample are this. Okay, so you have to identify first what are the groups, what are the blocks. Okay, so later if we have a look at the question or a problem, I'll show you what I mean by this. The second step is to rank the data within each block. So means, let's say we have the data and we know what's the block. Let's say here is block. To rank the data means here we don't rank the whole thing. Means we have to first identify the block and rank within the block. Means like if let's say the block is here, so it's going to be horizontal. I mean the data that we want to rank. Okay. And then calculate the sum of the ranks within column or within the treatment. Okay. Yeah, so once you have rank it, sum of the ranks is you add up the sum. The rank. You sum up the rank. Okay. And then the fourth step is to calculate f value. So this is the parameter of Friedman test, and this is the formula. So you have to know now here B refers to block, the number of block. So sometimes the block can be 2. Just now, if let's say gender, there are 2. So N is and block B is 2. But if let's say in some cases the B could be 3 or 4, so you have to use the right number. Okay. K here is the number of treatment or number of samples. So it's very important to identify the block and treatment correctly, because if let's say you assign it wrongly, then it will affect your F value, because B and K here will be used differently. Yeah? All right, so once you have calculated F, then you have to compare the F value that you have calculated with chi-square value. Okay, last time we talked about chi-square table, isn't it? Like in Wallis. So you have to use the same table in order to find the values of chi-square, because you want to compare the two values, the F and the chi-square. So now for this, the degree of freedom is the same. Okay, the way how you find the chi-square is still the same. Still same. V is degree of freedom, and also you have to know what's the alpha value that you are referring to. Yeah, sometimes it's given, sometimes it's not. So the normal values is 0.05 or 0.01. Okay. The rejection region. So this is the reject the null hypothesis if this condition is met. If F value is greater than the chi-square. Or the other way around. If F is less than chi-square, then you have to accept the null hypothesis. So this is the one that you have to remember. That's step number 5. The rest of it is the same as Wallis. So step number 5 is important because it will determine whether you proceed with step 6 until 7 or not. Okay, so is the rationale is the same. So if let's say in step 5 you accept null hypothesis, means there is no difference, isn't it? So there's no point for you to find further. So there's no difference, it's the same. School A is equal to school B is equal to school C, for example. But if let's say you reject the null hypothesis, means you accept alternative, and it means there is a difference. There is a difference between the samples. So means you have to figure out where is the difference. Sometimes the difference could be between sample 1 and sample 2, or treatment 1 and treatment 2, but it could be the same with the rest. But you have to find where's the difference. So that is the rationale of step 6 until step 8. Yeah. So step 6 until step 6 here is step 6 until step 7, because step 8 is actually you have to do it even though you don't do step 6 and 7. Okay, so the procedure here is called Bonferroni inequality procedure. It's the same like Wallis that we have covered last week. Okay, so you proceed with step 6 only if you reject the null hypothesis in step 5. So means in step 6, what you have to do next is you have to calculate the critical value. The critical value given by this formula. given by this formula. But first, if you see the formula, there is a Z value, isn't it? So you already know what's B, K, right? But you need to know Z first. So you cannot solve the critical value without knowing the Z value. So how are you going to solve the Z value? You have to use this information, okay? You have to solve the tell area first. So means that you have to refer to the standard table, standard normal table. So you have to solve the tell area first. The tell area is given by this formula. It's the same formula in Pascal-Wallis. Alpha divided by K multiplied by K minus 1. Alpha is, it depends on whether it's given or whether you have to define. Okay? K is the number of treatment, number of samples. So once you solve the tell area, so what's the tell area means? So the tell area means if it is in the normal table, so it's given in the tell. This is tell. Okay, this is tell area. So shaded area is the the shaded region is the area. So this is the tell area. So once let's say you solve the value, you got certain value 0.0 maybe 5. Okay. So this one you have to find the Z value that corresponds to this region. So how to find that? You have to know that the whole area here is 0.5. Right? That is the thing that you have to know by yourself, because that is the characteristics of normal, standard normal table. So in order to know this area, let's say A, so you have to minus 0.5 minus the tell area. Okay, so you will get the area here. So only then you can refer to the standard table, standard normal table. Here. So only then you can refer to the, let's say the value is, I just take one example, 0.4917, isn't it? So you get the value from inside, isn't it? So this one, the nearest one, 4918. So your Z value will be 2.40. Okay, 40. So that is Z value. So only then you can substitute that value into this formula and solve for the critical value. So remember, the Z value itself is not yet critical value. Critical value is given by this formula. Okay, so that's the critical value in 6 steps. And then step 7 is to find this expression. Okay, this one. So this one, please take note of this symbol is the absolute value. Means that you're not going to have any negative value. Whatever negative inside that, it will be positive. Yeah. So Sij, you actually you develop or you match, you create possible pairs. The same thing like Pascal-Wallis. Let's say you have 3 samples. Let's say you have whatever the sample 1, 2, 3. So Sij, it could be S12, S13, S23. Okay. And you have to find, this one is actually the sum of ranks. The S is refers to the sum of ranks. So for every sample, you have the sum of ranks. So you have, okay, I'll show later. So you have to figure out this and compare with the critical value. And the condition is to reject the null hypothesis if the absolute value of Si minus Sj is greater than the critical value. So means that for every pair, you would make a conclusion whether it accepts or reject the null hypothesis. So if it accepts the null hypothesis, means there is no difference between sample 1 and sample 2. That's what it means. Okay. So you have to come up with conclusions for every pair. So once you have done step 7, then you conclude. The last step is to make a conclusion. So means here you have to state the pairs that have a difference and the pairs that do not have a difference. Okay? So the two conditions that you have to state. So yeah, that is the 8th or the last step. The final one is always the conclusion. Okay, now let's have a look at an example. So this is an example of a problem that requires you to use Friedman tests. Okay, so let's analyze the data. To compare the popularity of 5 politicians, the following popularity scores were obtained over a 6-month period. Okay, sometimes in the questions, it is not stated which one is block, which one is treatment. Okay, for example, here it says, the last one here, it says that there are 6 blocks, or you know that here is block, and politicians A, B, C, D, E are treatments. But assuming that, let's say, this information is not given, okay, this information is not given, test the data using alpha 10%. Okay, this one is given, which is 0.1. Okay, let's say the information is up to here only. So how are you going to know whether which one is treatment, which one is block? Okay, so you go back to the question. So normally, when we talk about samples, okay, so the first thing, I mentioned just now, sample is always the equal to treatment, isn't it? Or group. So meaning to say that that represent the whole data that we want to compare. Okay, so here, obviously, the first sentence, to compare the popularity of 5 politicians. So obviously, we know that we are comparing the politicians. That is our subject of comparison. So this is actually the treatment, okay, or the sample. So from here, you can assign, you can identify directly that is the sample. So when you know that that is a sample, so obviously the second factor, which is the month over here, this is the block. Okay, and this is, you label it in your data so that you don't confuse. So the treatment N is, oh, the K, treatment is K, right? So K is 5, B is 6. So that's how you identify B and K. Okay. Right. So let's apply the steps. So the first step, the hypothesis, null hypothesis, they have the same popularity or there is no difference between the politicians. Okay. Maybe you want to say more specific, the politicians. Okay. And for the alternative, at least one differs in popularity from the others. Right. So okay, so just now, this is the data. This is the original data given to you, right? So have a look at the second step. The second step is to rank the data within each block. Okay, so go back to our data here. So now we know that this is block 1, block 2, block 3, block 4, block 5, and 6. So we have to rank within the block. So means, let's say for block 1, rank is from the lowest to the highest, isn't it? So the lowest here is 11. So let's say. So this is rank 1. Number 2 is 40. 2, 3, 4, and 5. Okay, so that is the rank within the block. And remember, if let's say there are 2 similar values or 3, so you have to apply type ranks. So type ranks is applicable whenever you have the same values. Yeah, but in this case, we don't have the same values. So that is what you have to do for step number 2, to rank within the blocks. So it's actually much simpler than the previous test where you have to rank the full data, isn't it? So this one is not that really tedious. So for example, block 2, you rank from 10. So this one is the similar value, isn't it? So you have to apply the type ranks. So the ranks that we're supposed to assign should be rank number 1 and rank number 2. And there are two similar data, so we divide by 2. So it's 3 divided by 2 is 1.5. So the rank that we assign to both is 1.5 instead of 1 and 2. And the next rank is 3, isn't it? So the third one is here, 3, 4, and 5. Okay, so that is the rank for block number 2. So you'll do the same for the rest of it. Okay, so once you rank it, you will have the values of rank. So please don't get confused with these values, the ranks, and the original value or the data. Okay, so because if sometimes you don't label it correctly, you might sum up the real data instead of rank, because later after this we are going to sum of the ranks, isn't it? We have to sum the ranks of the block. Okay, so you label it correctly in your workup. These are ranks. So now here are all the ranks. So what we have to do next is step number 3. Calculate the sum of ranks. You have a look at your Instagram, Telegram, the steps, the steps that I forwarded, so I don't have to scroll back and forth. So step number 3 is calculate the sum of ranks within the treatment. Okay, now, so we know that this one is treatment, isn't it? And this is block. So just now you rank within the block. But now if you want to calculate the sum of the ranks, so you have to sum within the treatment. So this is treatment A, isn't it? So these are the ranks of treatment A. So you sum it, 4 plus 3 plus 3 plus 3 plus 3.5. So it's equal to 19.5. Okay. And you do the same for treatment B, treatment C, D, and E. So you get this value. So this is the SI. So here means that this is SA. I is just to refer, I is just the general symbol. Okay, but when you have A, it's SA. And then this one is SB. This one is S. You label also the sum of the ranks, because later you have to match the pairs. And this is SE. Okay. So that is the step number 3. Step number 4 is to calculate F. So the F formula is given just now. F is equal to 12 K plus 1 summation of SI square minus 3B K plus 1. Okay. So if you see here, there are few terms, and you have to be careful with the terms. For example, this one, okay, SI square. So I is referring to each of the sample. So you have to make sure that you sum these values first and correctly before you multiply with 12 divided by BK times K plus 1. Okay, so here we have 19.5, 25.5, 26, 7.5, 11.5. So those are the SI, isn't it? So this is A. So this is A, B, C, D, and E. Okay, but it must be squared. So yeah, so that's the square value. And 12 is 12. B is 6. Remember just now, the block? There are 6 blocks. So B is 6. K, there are 5K, right? The treatment. So you multiply, you substitute this into the expression. And the last part here is 3B, 6, K is 5 plus 1. Okay, so be careful with the bracket so that you don't miscalculate. Okay, so once you have solved this, so the value of F is given as 18.33. So that is F value. So now you have to find the chi-square value, isn't it? If you refer to the step number 5. So you have to compare F and chi-square values. So it means we have to find out what's the chi-square values. So our degree of freedom is K minus 1. K is 5 minus 1. So the V degree of freedom is 4. And our alpha is 0.1, given in the question. So you convert it into decimal, it's 0.1. So let's have a look at the chi-square table. So alpha 0.1. Okay, so this is the one that we have to refer. And 5 our B is K minus 1. 5 minus 1 is 4. So here, isn't it? B is 4. So our value here is 7.779. So that is our chi-square value. So bring this value to our workout just now. 7. Yeah, here. So our value, our chi-square is this one. So our F is 18.33. So our F value is greater than the chi-square value. So means that we reject the null hypothesis. So at this point, we reject the null hypothesis, and you can see that there is a difference in the score of the politicians, the 5 politicians. It's not of the same thing. So we continue with 6th step or the Bonferroni inequality procedure. Right, so what the 6th step is, we have to calculate the critical value. Okay, so this expression. So we already know what's the B, which is 6, K is 5, and we need to know what's Z. So in order to find Z, we have to find first the tail area, this one. Yeah? So our alpha just now, okay, tail area is equal to alpha divided by K minus 1. So alpha is 0.1, right? And K is 5. 5 minus 1 is 4. So the value here is 0.005. So that is the tail area. So now we have to look in the standard table. So our values is, okay, you draw the tail area so that you can imagine which area that you are looking for. Yeah? So this one is 0, 0, 5. 5. Okay, so we need to find the Z here. So we know that the whole area on this side is 0.5. So this one should be 0.5 minus 0.005, which is 0.495. So knowing this value, only then we can find the Z value, isn't it? So means we have to find 0.495. The nearest one is this one. Okay, So that will bring us the value of Z 2.58. So this one is, yeah. So our Z value is 2.58. So this is the value that we substitute into the formula just now. So 2.58. And insert everything lah. The B equal to 6, K is 5, K plus 1. Yeah? So once you have solved that, what's the critical value there? Yeah, so yeah, this one. What's that thing? 2.570. It's actually, if you take this one or in the middle also can lah. If you round it up, it will be actually 2.58. So it's just not that really much difference. Okay, so you substitute the values, you got this critical value. This is a critical value. So what you have to do next is, if you refer to the step, calculate the critical value. Okay, step number 7 is to find the Sij. Okay, so means now, just now we have the SA, SB, SC, right? The sum of the ranks. So you have to, if let's say you don't order it also can, you just list it down. You just list it down, okay? So that whenever you find the difference, because we need to match every pair, and we need to match every sample to make a pair. So for example, SA B, SAC, SAD, SAE, isn't it? So that's the possible pair. And then we start with B, SB, C, SB, D, SBE. I hope you understand what I'm doing now. I'm matching the sample because we want to compare the pair. SBE, okay. The next one is SCD, SCE. And then the last one is SDE. So the order is not, it doesn't matter. SAB is equal to SBA. So that's why I don't write down SBA. Yeah? So SAB, AC, AD. How you match it? You just match one by one. Yeah? AB, AC, AD, AE, BC, BD, BE, CD, CE, and finally CDE. Okay. So altogether there are 10 pairs. 10 pairs. Yep. 10 pairs. So what you have to do with all the pairs, for example, SAB, so the sum of the ranks, like 19, okay, don't forget that you have this absolute value, 19.5 minus B is 25.5. So if you don't have the symbol, absolute value symbol, it will be negative, isn't it? But because of you have that bar, that absolute value, so it would be positive. So you only consider 6, not negative 6. So this value is the one that you have to compare with. I think this one, nanti I betulkan balik sini ada correction dah ni. Okay, so you list down SAB, SAC, how much, yeah, the difference, and this value is the one that you compare with the critical value. So if you refer back to the steps just now, so you reject the null hypothesis if, let's go back. This one. So you reject the null hypothesis if the difference of Sij is greater than the critical value. Means that for every pair, you have to make a decision. So this is what we call decision. Reject null or accept null. Okay, based on this condition. Okay. So I have to correct this, but basically what you have to do just now is like that. So for every pair, you have to decide, for example, 6, is it greater than the critical value? No, it's less, right? So we accept the null hypothesis and so on. Okay. So at the end, so once you have all the list of the decision, the last step is to make a conclusion. So means that you have to state in your statement at alpha equal to 10%, there are 3 pairs that reject the null hypothesis, means there is a difference between those pairs. Reject null means there is a difference. And another point is there are 3 pairs that do not have differences in their means because they accept the null hypothesis. Okay, so in the conclusion, there must be 2 conditions stated: which pairs that have a difference and which pairs that do not have a difference. So the marks normally are 2 marks. So if you just state one condition, we got 1 mark only. So that's why you have to state 2 conditions, that 2 conditions. Okay, so that's how you solve a problem using a Friedman test. So if you have familiarized yourself with Prasco-Willis, so this is just another extension, I can say, or maybe, yeah, there is a similarity, isn't it? So you can expect how to solve it. So it's just that you have to calculate F parameter. Yeah, and you have to compare different the F with just now what the F with the chi-square, right? And then after that, you calculate the critical value. The formula is different from Prasco-Willis, but we compare the critical value with the difference of every pair and make a decision based on that. Okay, so there are 2 questions here. In the first exercise here, the first question here is stated directly what is block and what is treatment. So that one is, there is no problem for you to identify. But another one, I think, okay, so in another problem, it is not stated which one is block, which one is treatment. Okay, let's have a look at this question. In a comparison of the prices of items at 5 supermarkets. So obviously we are comparing supermarkets. So from there, you know that this is actually the treatment. Okay, so that's why you have to understand the problem carefully, what you are comparing. So this one, obviously, you know, this is the treatment. So that's how you identify the treatment. So the next factor will be the block. Okay, for example, here we have different items. So this is block. Okay, 6 items were randomly selected and the price recorded for 5. Okay, the objective is to see whether the data indicated differences in the levels of prices among 5 supermarkets. So this is actually the ultimate aim, to check, to compare the 5 supermarkets. So that's how you identify the treatment. Yeah, the rest is you apply the same thing, all the steps just now. Yeah, alpha is given at 0.05. Okay, so I leave it to you, exercise 1 and exercise 2. Yeah, so that's it for today. And that what we have covered for LU2. And our midterm exam is up to LU2, LU1 and LU2. Okay, so please make sure that you have mastered all the tests for LU2. And for the midterm exam, yeah, I will post the date, but it's going to be after Raya. And the way how the exams will be, I don't remember the first and the second part. It should be sometimes MCQ, but the the one that have more marks will be the last section, and the questions will be the same as the tutorial or the exercise like this. So you know the nature of the questions is the same. So you have to solve it. You have to yeah, you have to indicate the step clearly. So if you just follow whatever the steps given or the examples given, you know, you don't have problem to answer the exam. So it's just that you have to remember the first step, hypothesis, last step, conclusion. Okay. All right. So I think the exercises for you on your own, yeah, to solve. Right. So that's it for today's topic, Friedman test. So LU2 we have sign tests, Wilkinson, Man with Me, Roscoe-Wallace, and Friedman test. So altogether there are 5 tests that we have to master. Okay. Don't have any questions? You may leave. Yeah, thank you for your attention. I'll share back the attendance.